In this video, we want to talk about the concept of proportion. So, introduction about proportion. In mathematics, proportion describes the relationship between two variables or two quantities. Where a change in one variable affects the other one in the same ratio. So let's look at and there are two types. Before we go into that, there are two types of proportion in mathematics. We have direct proportion, we have inverse proportion. So let's describe each of them one by one after the other. Direct proportion. Two quantities show direct proportion when they increase or decrease in the same proportion. Take for example, let's x and y represent two quantities. X is proportional to y if we have x this is symbolic representation of proportional sign, which implies x is equals to ky. So where k is the constant of proportionality, is the constant between them of proportionality. So what this means is that by direct proportion, what it means is that if one of the quantities increases, the other one will increase as well. If one of the quantities decreases, the other one will decrease as well. So graphically, it could be like this. Something like this, this graph, and it moves like this. It will definitely pass through the origin. So the direct proportion will pass through the origin. You can see that it's increasing. I can have the decreasing one as well, but definitely the direct proportion must be a straight line that passes through the origin. So this is a very good example of direct proportion. Okay, now let's look at an example. Let's illustrate this with a very simple example. So now, example 1. Example 1. If 1 pen, or let's say 1 pencil, costs $3, how much will 6 pencils cost? 6 pencils cost? This is a very beautiful question, because this is talking about, you can see that a pencil costs $3. Now when it is now 6 pencils, obviously you can see the number of pencils has increased. So definitely for direct proportion, there will be when one constant, or when quantity increases, the other one increases as well, vice versa. So you can just like say, let x represent the number of pencils. You can see pencil, and let y represent the cost of the pencil. As you can see, pencil is sold for $3. Now, obviously, from our proportional equation that we have just written, you can say that x is 1, so y is $3. So obviously means that implies that one pencil equal $3, of course. So 6 pencils now will now be equals to 1 times $3. Sorry, 6 times $3. Sorry about that. And that will be what? That will be equals to $18. So that is it. If one pencil costs $3, 6 of it will now be that. So that is what we call direct proportion. And this has a real life application in distance travel versus time when the speed is constant. It also has an application in the quantity of food versus the number of people that eat when a fixed portion of food is given. So the more the number of people, the more the quantity of food they consume. So we also have it in let's say work done per number of workers if time is fixed. If time is fixed, that's the statement there. Work done per versus the number of workers if time is fixed. So let's look at the other one, which is talking about inverse proportion. Let's look at the second one. It talks about inverse proportion. Now for the inverse proportion, as we have really seen here in the direct one, inverse proportion. So just the opposite of two quantities are in inverse proportion. They are in inverse proportion if as one increases, the other one decreases. Okay, the other one decreases. So their product is usually what? Constant. The product of the two constant. The product of the two quantities is always constant. Constant. We shall say that now. That is, for example, x is inversely proportional to y. So that means x is equals to k over y. So by the time we cross multiply, this constant proportionality will k will be equals to x, y. So you can see that the product of x and y is constant. Okay. Let's look at an example. Very good example. Example 2 here. Okay. Now, if 8 workers take 6 hours to paint a house, how long, that is the number of time, will it take 16 workers? You can see this is beautiful. This is beautiful. Now, how do we solve this? You can see that the number of workers initially is 8. Like x is 8, y is 6. So 8 workers spent 6 hours. Now, then to paint a house, how long will it now take 16 workers? You can see that when the number of workers doubles, because 16 is a double figure for 8, what will now be the number of hours they will spend? You see, the more the number of workers, the less number of time they spend. So that's from here you can see 1 worker now will spend 6 times 8 hours. Yes, that's 1 worker. Which means 1 worker will spend 48 hours. Now, for 16 workers, because it's an inverse proportion, because the number of workers have increased, has become double. And what we now spend, 48 all over 16, which is equal to 3 hours. You are not multiplying 16 by 48. Oh, no. You have to divide, because this is an inverse proportion. One of the qualities or quantities of inverse proportion is that, like I said, it's when the number of work, when one increases, the other one decreases. When one doubles, the other one halves. 16 is a double form of 8. That is 2 times 8 gives us 16. So the half of the hours now will be 3 hours. That's just it. That's just it. So, and this is mainly used when the number of time given to workers, this is like workers versus the work they are given, the number of hours given is not constant. So definitely it will be, it will decrease. The more the number of workers, the less the number of hours they are going to spend. And in that case, like we have seen here, because the number of workers has doubled, so the number of hours will be halved. So with this, we have come to the end of this short video on proportion. So do well to click on the notification bell so that each time I upload a video, you'll be duly notified. I'm Dr. Hoji. And as well, share the link of my channel, and like it. So hoping we meet again in another video. Thank you. God bless you.